Let us discuss today about the refraction of light through spherical lenses. Spherical lenses. There are two types of spherical lenses, convex lens and concave lens. See this face. This is total glass. If you see, this is the vertical projection. If you see here from this side, the shape will be like a disc, round disc. This portion, the middle portion is this one. This middle portion is bulges. Now two spherical surfaces are joined together in this way. In this way. This portion is thicker and the sides of this disc is this one. So this is thinner. So this type of lens is called convex lens. When the two spherical portions of the glass are joined together, this is called convex lens. And when these spherical surfaces, let it be divided by a thin line. This is the center line. Let this be the center line. This is one portion. This is other portion. Now, when these are joined in such a way that this is thick in the middle and thin at the sides, this disc, when we see from this side, this will be, the shape will be this one. This is called convex lens, and when this half is joined here, the round surfaces are joined in such a way that when we see this from this side, the shape will come a circular shape. But here, the center point is thinner and the sides are thick. Here it is thick. Here it is at the side, it's thick. Sides are thick. Side of the disc are thick and the middle point is thin in this way. So this one is called concave lens. Now we will see some terms related to lens. Let it be a convex lens. So the middle point of the lens, this one. For example, here I have drawn a disc. Yeah. If you see from sides, this will come in this point. This point is called 1. If you draw a line passing from this point, it's a horizontal line, to the point, this point is called C, optical center. C is called ऑप्टिकल सेंटर. बार बार ये यूज होगा, इसलिए आप ध्यान से देखिए. ऑप्टिकल सेंटर ऑफ द लेंस. दिस इज द ऑप्टिकल सेंटर ऑफ द लेंस and a line passing through the optical center. This line, this is the vertical line in this figure, and horizontal line in this figure is called the principal axis, this line, and a point here is called the focus. And at the equal distance, this distance here, it is 2f. These points are denoted, the focus is denoted by f, and twice of focus is written here. So these are terminologies used in the lenses. Now, the example of convex lens is the reading glass. You would have seen that palmist जो ज्योतिषी होते हैं हाथ की रेखाएं देखने के लिए, for reading your lines of palms, they use a lens, round lens with a handle. It is fitted with a handle. In the frame, the lens is fitted. This lens is fitted in the frame, and he used in this way to read the lines of the palm. तो palmistry वाले use करते हैं. So this is the convex lens. Now let us proceed how the images are formed by the lenses. So there are some rules, as in case of mirrors. The lenses have got some rules for formation of images. First rule is, this is the convex lens, this is the axis, and this is the optical point. This is F, focus, and this is 2F. If the focal length, this is distance, CF is F, focal length, denoted by F. Focal length. So now, in this case, the incident rays coming parallel to the principal axis, they will, since this is a lens, this will not reflect the light, this will allow the rays to pass through it. So here is also a focus in this side. The rays will converge and meet at focus. After refraction, when passing through the glass, they will meet here. This is called focus. So this is rule 1. We are discussing formation of images. Note down how the image is formed. The rule first. Very simple. This is the rule. First, incident rays parallel to principal axis after refraction will converge and meet at the point, converge to a point called F, focus. parallel rays will meet at focus. Rule 2. Rule 2. Let there be some object. Let here be some object. Object is always put above the principal axis. This is the head of the object, and this is point A, this is point B. Now, if a ray passing through the center, optical center, this will pass straight, other side of the lens. This will not deviate. This is the formula. Similarly, along this, any ray along this principal axis, that is principal axis is passing through, say, so the ray will not refract in any direction. This will be also go in this direction. You can make an object or simply a ray passing straight through the point C will follow the same direction after passing from the lens. And number 3, a ray, suppose a ray, whether it's passing through the focus, let us extend. It is passing through the focus straight. This is focus F. If a ray, incident ray, passing through the focus after refraction, that will be parallel to the principal axis. The reverse of rule first. The refracted ray will be parallel to the principal axis. These are 3 rules for making image from a lens. Now we will discuss the formation of images by a convex lens. How the image is formed. The same way, in case of mirrors, in case of reflection, the rays were reflected from the mirror. Now in case of lenses, it is clear, it is transparent, so the rays will pass through the glass. But these rules are followed, the rules of refraction by lenses, spherical lenses. So let us take this how many positions can be of the object between the optical center C and focus F. First thing, formation of images. This is the point C, this is the F, and this is the 2F. The first case is the object is put between the optical center C and focus F here. This will be here. Second case, the object may be at F. Third case, the object may be between F and 2F. And next case will be object may be here 2F, and other case beyond 2F, and next one the object is at infinity. So now let us take one by one. When the object is between C and F, when the object is between C and F, let this be object A, B. This is your optical principal axis. Now take a ray parallel to the principal axis. आप दो तीन प्रकार की ही रे लेंगे, ले ही सकते हैं जो रूल फॉलो करें, जैसे पैरेलल टू द प्रिंसिपल एक्सिस and a ray passing through the focus, a ray passing, number 3, ray passing through the optical center C. So for formation of images, minimum 2 rays are necessary, so that they may cut at some point, and we decide the location of the image of that point of object. Let this, we start from the head of this object A, the point A. Let us start. This is the incident ray parallel, and after reflection, after refraction, not reflection, if it is the F, this 2, what happens? It is parallel ray. So after coming out from the glass, it's be trouble in the glass. After coming out from the glass, this will focus, this will pass from the focus. It is parallel, so it will pass from the focus. Now you can take the next ray here from this, that is passing through the optical center. You will proceed here. This will cut. Oh, sorry. This has been the wrong formation. It is very nearer to this one. It will pass from the focus, and when this will pass from here, so this will pass in this way, straight. Let us use some different color. So this is the second ray. So what happens? They will diverge here. As you see, the rays are diverting, so they will not meet here. And when you will see from here, you will see from this, at this point, the both ray will seem coming from some point here. You will extend them in the backward direction. So there a point will come where they meet. Let this be this. Let it be the point here, A dash, and this is the principal axis. This is point B dash. This is the head of the image. So what happens? The rays, when seen from here, you will observe that this ray is coming from along this line, and this ray is coming along this line, and both meet at this point when extended backward. So when the image is in between the optical center and focus, the image formed by the lens will be here towards the object. But since the rays don't actually meet, these rays are, you can feel that this ray is coming from here and this ray is coming from here, and both cut here, so the image of A will be formed at here, A dash. So this A dash B dash is the image of the object AB. So this image is not real, this is a virtual. What about the image, the quality of image? In this case, when the object is between C and F, the image is number one, it is not real, it is virtual. Why virtual? The rays don't actually cut each other. They seems cutting each other. The image is virtual. Number two, object is in reduction, image is also erect. So it is erect. सीधी है. Number 3, it is big inside as compared to object, so magnified. It is magnified, enlarged or magnified, larger than the image. So this is the case when the object is between C and F, optical center and focus. Now the next case. Next case is, let us this is the lens, this is the principal axis, this is the point C, this is the F, this is the 2F. Now let the second case. In first case we have seen the object was between C and F. Now let it be on, the object is on F. This is A, this is B. Object is on F. Now take a ray here at the same distance in this side, this is F, this is 2F. This is a ray parallel to the principal axis, and this side this will pass from the focus. Here, if you take the second ray, it is passing from the optical center, and you find that these rays are parallel. This is incident ray. After refraction, this will not change the direction, this will go in this side, but the first one which was parallel to this axis will pass from the focus. This one is passing from the center, optical center, so this will pass straight. And practically we find that these are parallel rays. Parallel. Refracted rays are parallel. So where these rays will meet, it is assumed that they will meet at very far off distance, at infinity. So what about the image, the quality of image? In this case, about the image, the case is object is at focus, F-O-C-U-S. Then we describing the image. Number 1, location image की. Image is at infinity, अनंत पे बनेगा location. Number 2, at the real rays are going in this side, so image will be real. And since the head is on this side, upside the above the principal axis and the rays are going below the principal axis, so the image will be inverted, उल्टी बनेगी, image will be inverted. And number 4, size. साइज क्या होगी इमेज की? हाईली enlarged. Highly enlarged as compared to object. Means A dash B dash will be more greater than AB. Okay, let us take the next case. Next case, that image is in between F and 2F. Let us now, in this case, image is between F and 2F. Let it be here. This is A, this is B. Let us find out the image of the object. The object is between between focus and F and 2F. This is the case. Now, the first ray, take this ray. This is parallel to principal axis. So this will, after refraction, this will pass through focus. Now the object has shifted here. Now take second ray, which is from this point, passes from the focus. So when array incident ray passes from the focus, after refraction will go parallel to principal axis. So they will meet at some point here. So this will be the image A dash. A की यहाँ बनेगी और ये बॉटम यहाँ तक, यहाँ B dash. So this is the case. If instead of taking this ray, you can take this ray that passes through this point. So let us take this ray also here. So this will also reach, this will not deviate, and this will reach the same point. You can take more than 2 rays. You can take the beam of rays. But each and every ray will follow the rule of refraction. So this will be the image. So let us find out the description of the image. In this case, whenever object is in between F and 2F. What about the image? You see clearly the rays are cutting each other after refraction. Actually they are meeting at this point. So about the image, number 1, the rays are actually meeting this point. So the image is real. And you see whether it is erect or inverted, the which is inverted. Size big, number 3, magnified or enlarged. manganese. The words are different but same thing. Or you say enlarged. And on the other side of the lens, the location, and it is beyond 2f. f और 2f के बीच में ऑब्जेक्ट है, तो image, if the object is between f and 2f, the image will be beyond 2f on the other side of the lens. The location is other side of lens beyond 2f. Okay. Now let us proceed further. Now the next case. The next case is object is object is at 2f. लिखने की क्या बात है, ये यहाँ बनाइए. This object is at here. A dash, this is the head, and this point is the bottom. AB is object. Now take this ray parallel to principal axis. After refraction, this will proceed in this direction and pass from the focus. Rule first. Apply the rule first. Now take second ray. Which one? Let it the second ray passing from the focus. So incident ray which passes from the focus after refraction becomes parallel to principal axis. So this will meet here. This is point 2f. So this will cut. This is 2f. So this is B dash. This is A dash. This is the ray. This is going in this direction. This was the first ray which was incident parallel after refraction pass from the focus. The second incident ray passing from the focus after refraction go parallel to principal axis. Naturally, as in case of mirrors, it is also just like mirror. So here after refraction, the image, the lines, these rays cut actually at this point. So image is real, okay. It is inverted. And number 3. सेम साइज जो है सेम साइज मीन्स ए बी इज इक्वल टू ए डैश बी डैश. Other side of lens and not beyond 2f at 2f. This is about the image, description of the image. Now the next case, there is also a next case. Let us मिटा दें इसे. Let us remove. Let us remove one. Let us make fresh figure. Let us make fresh sketch. This is your lens. This is your axis, principal axis. This point is C. This is F. This is 2F. Here this is F. This is 2F. Now the image is beyond 2F. Let see the axis. Let it be here. Let the object is put here. A, B is the object. AB is the object. A is head, upside of the object, B is the bottom. So we start. Take a ray parallel. This is very easy. Take an incident ray parallel to the principal axis, and after refraction, after passing from the lens, when it emerges the body of the lens, this will pass from the focus. Now, you can take a ray that passes from the C, or you can take the ray passes from the F. Let us take this one. Passes from F. So this is passes from the focus. So after refraction, after emerging the lens, this will become parallel. This will become parallel. The two rays starting from A, after refraction they are cutting at this point. So this is A dash. Let us use different color. This is A dash. This is the head, and this is the point B dash. Image of A at A. Image of A at A dash and image of B at B dash. So A dash B dash is the image. Object का image वहाँ बना. The image of the object AB is A dash B dash. So let us describe the image. This is the case when object is put beyond the 2F. The image description, quality of image. Number 1. We see the rays are meeting in actual here. So it is a real image. Number 2. The head is upside, object का head. The head of the object is upside, but the head of the image is toward below and other side. So it is inverted, not inverted. Number 3. It is in this side between location है between F and 2F. Naturally, you see the object is moving in this direction. So the image is moving in this direction. When this was at F, that was a peculiar case when the object was between C and F. Image was on this side. That was virtual, only one case. And when it is focused, the image was on this side at the infinity. When it moved here, in this side, between F and 2F, when it reaches at this point, when it was between, the object was between F and 2F, the image was coming from infinity to this side and reaches beyond 2F. And when the object is moved to 2F, the image further moved and reaches at 2F. Now the object is beyond 2F. The image is also from 2F to this side, F2. Now further the object will go on infinity, the image will reach at focus. So this between F and 2F, number 4. The size of the image, you know, it is diminished. इसमें बहुत क्लियर नहीं हो रहा है, बहुत बढ़िया से बनाया जाएगा. Then you will see that it is, the size is less. The size of the image is less than that of diminished means A dash B dash is less than AB. इमेज की साइज जो है, लेंथ जो है छोटी है. And it is on the other side of the lens. Okay, now a case, second case is there, let us remove it. Let us remove the object from this point. Now the next case is, your image is very far. The rays are coming parallel. The image is at infinity. This is also a ray. This is also a ray. This is also a ray. So these rays falling on this lens, they will reach here. They will converge and meet at this point. This is straight passing from the optical center. So this will not refracted, the direction will not change. This will pass through. So they all will meet here. Focus here. Focus will meet here. So this is the case, last case, when the object is at infinity. Object is at infinity. Now the quality of image, the description of image. Number 1, position on focus. Other side, the image की position on focus. Other side of lens. Number 2, Since rays are meeting, actually they meet at this point, so it is real. Number 3, all the rays are meeting at a single point, pinpoint. So diminished image is diminished any small in size. Highly diminished, you can take very small. Highly diminished. Here number 3 you will write clearly highly diminished. ऑब्जेक्ट बहुत बड़ी है तो बहुत छोटी सी इमेज बनेगी. Highly diminished and very small in size means A dash B dash is very less than AB. The characteristic arguments we have written here, we have discussed. Now, some interesting things about the convex lens. Only one thing. You see that the light rays coming parallel light rays are reaching here and converging to a pinpoint. So what will happen if we put a paper here at this point? If we put a paper, and generally in books it is given carbon paper or black paper. So what happens? A hole is burnt in the paper. Why? This radiation, solar radiation, insolation, these are called insolation, means incoming solar radiation. Incoming solar radiations. One word, insolation. मतलब सोलर एनर्जी. आप देख रहे होंगे nowadays the big solar plants are being installed in India also, and there have been a good production, good generation of solar energy in the India grid. In UP also there are many solar power plants. Some are up to the capacity of 50 megawatt. This is very higher capacity. So this insolation, this radiation, incoming solar radiations have much energy, much heat. When these all are concentrated at some point, the heat, so much heat is generated at that point, because all the rays are coming and reaching, focusing at this point. So a lot of heat energy is generated, and that energy burns the paper. And why the black paper or carbon paper? Because you know that is a black body. ब्लैक बॉडी हीट रेडिएट भी करती है और हीट एब्जॉर्ब भी करती है बढ़िया से. इट इज द ब्लैक थिंग इज गुड एब्जॉर्बेंट ऑफ द हीट, गुड एब्जॉर्बर एंड गुड रेडिएंट आल्सो. सो व्हेन द रेस आर focused here the heat energy is generated and total heat energy is received by that black body, that black paper, and so the paper burns easily. Okay. One thing about these solar energy, Shirdi Sai Baba ke यहाँ the kitchen, on the top of kitchen, very heavy round mirrors, convex mirrors are installed, and the heat rays, so very large convex mirror are installed, and this much solar radiation from a large area coming from the sun, the solar energy coming from the sun. This is the principal axis, is collected at this point, the focus. This is the boiler. So all the rays reach here. What happens? This is the point. It gets heated, so much heated that when you put a wood, it will burn in no time. Within 20 seconds, 30 seconds, the wood will catch fire. So much heat is generated here by these rays. So in this way, they use these heat rays to generate steam for cooking the food. Okay, let us finish here and we will take numericals in next class. Thank you.